Hi class, today's lab is titration, determining the concentration of an acid. Acid-base titration. Titration is the process of adding a measured volume of an acid or base of known molarity to an acid or base of an unknown molarity until neutralization occurs to determine the concentration of the analyte. Simply stated, you will be using a concentration of a known molarity. In this case, it'll be the base, sodium hydroxide, and your volume will be the titration amount that reaches the end point. That's your volume. You will have on the bottom an acid that you will not know the concentration, but you will have a volume. You'll have a known volume that you put into that flask. How will you know when to stop? A color change. You will have an indicator. In this case, it's phenolphthalein, but you won't need to worry about the name of it. It is a colorless solution in acidic conditions, and it is pink when it reaches a pH of approximately 8. Since an acid is in a low pH, it will take a little bit of time to rise. In a simple acid-base titration, the indicator tells you when the acid and the alkali have mixed in exactly the right proportions to neutralize each other out. If you look down at the bottom, this is a general equation. You have an acid and you have a base. And when they are neutralized, you have water and a salt. That's why this is a neutralization reaction. When the indicator changes color, this is often described as the endpoint. When you reach the endpoint, when you reach the faint pink, it will your titration stops, and you will record the volume that you used with your known molarity. Here is a picture of a titration. You have an analyte. The analyte is the unknown concentration. It's usually on the counter. That's the acid in this case. You will have the volume. You will know the volume. The titrant is the solution, in this case the base, that you will know the volume once the titration has reached the endpoint, but you will automatically already know the concentration. The pipette, I'm not going to cover that too much. There's the videos that you should be watching. This lab is written fairly well compared to the other lab flow labs, and it does cover that information. If you look at the barrette begins at 0 and it ends at 50. You never want to go above this, and you never want to go past this. There's no increments. You wouldn't know the amount that you have. So if you start around 0, it goes down, and it'll go 1, 2, 3, 4, and let's say we stop here, and this is 23.25. You will take the final volume out minus the initial, and that will give you the titrant volume. As you can see, this is pink. You should always have a white piece of paper underneath here. It will allow you to see the color change easier. This is a very long instrument, you should always use a funnel to avoid spilling on yourself. And the stopcock, which is this orange little knob here, should be closed, because this is a very long instrument, and a lot of students leave this open and they don't realize that they have now poured base on their shoes, the floor, and the countertop. How to read a barrette. Now there's two spellings here, both are the same. I'm not sure why there's two, but I'm listing them both. You always want to read the bottom of the meniscus. If you look at this picture, depending on how you look at it, you are going to read it differently. You always want to read it at eye level. The bottom of the meniscus is what you will read. This is a very sensitive experiment that even being off a little bit can really throw your numbers off a lot. The this barrette is in increments of 0.1. That means this is 19, 19.1, 0.2, 0.3, 0.4, 0.5. This is known. So what do I mean by known? You have 19. This solution has passed 19. That's known. It has now passed 19.1. That's known. So let's say I have a solution here where my little arrow is. I now am at an unknown. There's no marked increments here. That is my unknown certain digit. So I would say this is 19.15. Somebody else might say that's 19.16. Basically, what you need to take away from this is 2 sig figs are required after the decimal point. Make sure you pay attention to that. I took this straight off the lab flow. They want you to always start not at 0, but past 0. Here's a hint. That might be a question for some of you guys. Do not pick 0. I don't know why I actually start my labs at 0, because it makes sense to have it at 0, because you don't have to go through this. Everything will always be final volume minus 0, but they do not want that, so make sure you follow their rules to get the points. So So here's a picture from their lab. You have a final volume minus your initial volume. That gives you the titrant amount. And notice it has 2 digits after the decimal point. The barrette has a knob on it. This is very important. This will determine if you are successful with your titration or not. It is a stopcock. When it is laying down or horizontal, that is considered closed. When it is standing up or parallel with the barrette, it is open. When do you need it open and when do you need it closed? Well, you want it closed when you are filling the barrette because all of this will spill out all over the place. And you want it open when you are starting your titration or you are cleaning and prepping the barrette. Why do you want it open when you're cleaning and still pouring solutions in? Because you want to rinse those out. You want to flush it out of impurities and also coat the inside walls of your barrette. It should be partially closed, partially opened. It depends how you want to state that, but it should be partially turned. As you get closer and closer to the color change, meaning the color change will last longer, then you want to start going by drops. And how many drops is up to you, and this is a very sensitive lab technique that even 1 drop can push you past the point. Air bubbles. Air bubbles are another thing you do not want. Air bubbles are, like I said, this experiment's very sensitive, so even having 1 air bubble can throw your measurements off. The indicator. These are samples of the indicator. This is phenolphthalein. It changes colors at approximately a pH of 8 at the end point. When the close to the end point, it will change color. So here you will start with a clear solution. Phenolphthalein is clear in acidic conditions. So what you can't see here are numbers that are written. So it'll stay clear in acidic conditions, and as it gets to approximately 8, it will change to a pale pink. This is not an easy thing to do. This takes a lot of patience in order to get to this color. 98% of my students end up with this. They pass the endpoint with every trial they do. Very few get a pale pink. Why? Because it takes patience. You have to literally do a drop by drop by drop, and most students and people, just people in general, not even students, don't have that patience. So that's why this color is very hard to attain. Why is it a big deal? Because you could have this and in 1 drop you will get that. That's how sensitive this is. So that means that you should have only did a half drop to get to the pale pink. Oh, and one more thing. I've had this happen every semester, if you are in lab and you did 2 trials and you kind of have an idea of where your endpoint is, and then with the 3rd trial you pass your endpoint and nothing's changing, chances are you didn't put indicator in your flask. I've had students argue with me. I end up dropping a few drops, and it is a very dark pink. So it's an easy thing to miss because it's a colorless solution, so you don't really catch that. So this lab is determining the percent of acetic acid in vinegar. Vinegar is an aqueous solution. It is acetic acid and water, and you are trying to determine how much acetic acid is in it. I'm giving you guys the equation. You can see that this is a monoprotic acid. That means that it's 1 proton. In some cases you would have 2 here. And this is just a simple summary again of what I've gone over. Titration involves the addition of a specific amount of base required to neutralize the acid. When the proton from the acid has been neutralized, the sample will change color. This color change determines the endpoint, which signals that you stop the base immediately and you record the volume. The phenolphthalein is the indicator, and it will change the color. It will change from colorless to a pink, depending on, it should ideally be a faint pink, and it could go to a dark pink depending on how past the endpoint you are. These are instructions taken from another lab. They're only minor differences from the lab flow lab, but this is a quick summary. There is more details, and you definitely should be reading your lab, but this is just an overview. You add 5 mils of vinegar into a flask that's pipetted. You're going to then add approximately 25 mils of DI water. Why are you adding water? To give it volume so you could see the color change easier. 5 mils, you wouldn't be able to see it. The water has nothing to do with your calculations. You are never going to use it. This is the only time I'm going to discuss it. Then you're going to add 2 to 3 drops of indicator. After prepping and conditioning your barrette, which you will watch in the videos, you are then going to load your base to the barrette. I'm going to say I started with my initial volume at 9.90 mils. The Brett is in mils. Then I'm going to have my flask with vinegar. That is the 5 mils of vinegar that's placed in the Brett. It's going to be underneath the Brett. Underneath the Brett on the counter, and I'm going to place a white piece of paper underneath so I can see, because a black countertop doesn't allow you to see the color change very well. I will swirl the flask in one hand as I add sodium hydroxide. As I near the end point, the pink color will stay longer, which means I'm going to slow down and slowly close the stopcock to only a very small drop at a time. And I'll eventually get to an endpoint, and my final volume is 23.21 mils. You normally do 2 to 3 trials, and you take the average, and the average is what you go forward with. Here's a quick overview of how to determine the molar concentration. You will always be given a molarity of one of the solutions, and then through titration, you will determine the volume. So what do you do with that? You cancel out the liters, and it gives you the moles. I should take a step back. Before you even do that, you absolutely need an equation. You need to have an equation. Why? Because the next step after this is going to tell you why. So it has to be complete, and it has to be balanced. I take the information I know, which is my concentration and my volume, and I get my moles of base. Now, this is a 1-to-1 molarity, which means, 1-to-1 molar ratio. That means that whatever I have of this is now of this. So my moles of base are now equal to my moles of acid. Here's the formula to determine your molarity of the acid. I take my moles of acid, and my volume, which would be in the flask, is down here. I change it to liters, will give me my molarity of HCl. So here, this is a very busy page, but these are all the calculations that LabFlow is asking you for. I do not do averages because I only did one trial, but I'll briefly go over averages with you on the next slide further down. So here's my equation. This is a 1-to-1 ratio. You have to make sure that you're dealing with a 1-to-1 ratio. And I have my initial volume and my final volume. I subtracted. I got my volume of titrants. My moles of base, I have that, which now means I have my moles of acid. I now need to get my molarity, which I have my moles over my volume of what I used in the titration for my acid. My mass of acetic acid is simply taking my moles and using the molar mass. So I have my moles, the moles cancel out. I now have my mass of acetic acid. My mass percent, in this case, there's 2 things you need to do. You have a density, and they're telling you what the density is. You use the density because you have mils. We can't use mils, we need grams. How do you get rid of mils? You cancel them out by using density. That now gives me 5 grams of vinegar. I already have my grams of acetic acid. I set them on top of each other, and it gives me 1.60% acetic acid in vinegar. That's what I came up with my mock trial. Percent air. It's asking you for the air. You will be given the correct value for yours, and what you do is you set up your experimental minus accepted and divide it by accepted. You have absolute values here. Those absolute values mean that even if you get a negative number, it's going to end up with a positive value. You would disregard the negative in front. So here's an example of a question. The correct value is 4.08. My experimental is 4.25. I set it up. I end up with a percent error of 4.17%. So let's go back to the lab. My value was 1.60. The value should have been 4.71%. So I set this up, and with the absolute values means that I have a positive number, not a negative value, and my error is 66%. This means that somewhere in the titration, I did not do the titration correct. My endpoint was wrong. I didn't reach completion, or I passed the endpoint. My steps are correct, but the titration was wrong. I've also added some questions that loosely, somewhat, I tried to match some of the questions that are being asked. Not all of you guys get the same questions. They rotate a lot out. I try to catch as many as I can. I do the lab a few times to try to see how many changes they make on it. And here's a question that could be given. This is somewhat similar to something you might be asked. What is the percent by mass of a 285 gram solution that contains 85 grams of solute? Make sure you understand what solution is and what solute means versus solvent. Set this up. The mass of solute goes on top, solution on the bottom. Times it. This is 29.8%. When you have the word percent by mass, it also means grams over grams. You're dealing with strictly grams over grams. Another question that could be asked, something similar to this, not exactly matching, but similar enough to be able to help you get started to attempt to answer these questions. 25 mils of a 1 molar potassium hydroxide was titrated to 56 mils of HCl. What is the molarity of the HCl? Remember, I've given you the definitions on top of titrant and analyte. So you understand which one is the titrant and which one is the analyte. Number 1 step out of 4 steps, write a balanced equation. Why? Because you need to know if this is a 1-to-1 molar ratio, and it won't always be, and you need to know that. Find the moles of the known solution. This is your titrant. Once you know the titrant, this is a 1-to-1 ratio, so now you know the moles of your analyte. You will put the analyte on top, the volume of the analyte on the bottom, and it will give you your molarity of your solution. How many grams of HCl? This is a 2-part question, so some of the information from the first will be used to answer the second question. How many grams of HCl are needed to neutralize 55 mils of a 0.500 molar solution? So you're only given a volume and a molarity, so that's all you can work with. So you cancel out the volume, gives you your moles, and then you can use the molar mass to get to grams. So if you're ever stuck on a question you don't know what to do, see if you can find a volume and a concentration that goes with that volume. That'll always get you to moles, and then you can figure out what's the next step in the question being asked. Is it asking for atoms, ions, molar mass, grams? You would use molar mass. Usually get anything to moles and then figure out what the next step is. Now, second part to this question, how many Cl atoms are in the 0.500 molar HCl solution? I'm taking the moles from here, where my arrow is, and I'm going to get atoms. Atoms, when you see the term atoms, ions, molecules, that means you got to use Avogadro's number. So I'm breaking this down. I have 1 mole of HCl, which gives me my 1 mole of Cl. When I want my 1 mole of Cl, I use Avogadro's number, and that will tell me how many atoms are in the solution of Cl atoms. Now, your lab is going to ask for several things being provided the average, so not just one. So in your case, I think you guys have 2 trials. In here, I have 3. So I know that this molarities would never exist, but we're going to pretend this is a molarity. So I've been asked for the average molarity. I have 3 trials. So I'm going to add my molarities, all 3 of them together, and then I'm going to divide by the number of trials that I had, and that's going to give me my average molarity. You will do this for every item that's being asked for an average. You take whatever it is, whether it's molarity, moles, add them together, how many trials, and then divide it by that number of trials, and that's going to give you your average for each item. Just make sure you grab the correct item that's being asked for each trial. I put together some terms in case you're having a problem understanding what some of these mean. This is for something for you guys to look at. I tried to make it as clear as possible. Here are some tips I learned from doing this lab. Never load the burette to 0 mark for the initial volume. Make sure you remove bubbles. This will affect the correct volume in the burette you're reading. Place a white paper underneath the flask. Make sure the correct indicator is used, or make sure you have indicator in your flask, or you will not reach the end point because it will not show. This titration, you want a pale pink color. You do not want dark pink. Pale, faint pink is the ideal endpoint color. You clean the burette with DI water multiple times when the experiment's done, and you always discard in a waste container. Nothing goes down the sink. In this lab, you are being asked to add some water. Like I said previously, the water is strictly for volume. You're not using it anywhere in the calculations. It's just to allow you to see the color. And if you ever get stuck on any of the calculations, look for a volume. Look for a concentration that goes with that. That'll get you to moles because the volumes will cancel out, and then you can see what your next step is. And now the last one is I'm giving you an answer. Not all of you may get this question. I wish I had wrote down the question now, but LabFlow's not user-friendly for an instructor. I have to enter data every single time to try to get answers. It doesn't let me just see the answer. I did this lab probably about 10 times just to try to see what different questions were asked, and I have to fill out every single part of it every time. There's a question I disagree with. I think what the question is asking for you to do is to calculate what the endpoint would be for your lab before you do the lab. And the question is not very clear, and I don't like it. So the first two parts would not be a problem for you to answer. I apologize if this is a little confusing, but as long as you guys write this down, if you see this sentence come up, you have the answer to it. There's 3 parts in this one question, and the last question is the one I disagree with because, like I said, I don't think the question's clear on this last question. It's clear on the other parts. Divide the moles of acid by the volume of acid solution before the titration to find the concentration of acid. Now, what I think that's saying is do your calculations before you start the titration, but it's not clear in the question. So I'm giving you this answer because I don't like this question. Okay? If you need help, post a question on discussion. Email me if nobody responds. Give it an hour, a couple hours, and I will post. I prefer that you guys help each other. I can always help you, and I'm not against helping students. But the reality is, students learn better from other students. I can give you an answer, but if I turn around and give you a question regarding that, most of you would not get it correct because you didn't learn it. And the only way you learn is by discussing and communicating and working through stuff. And that tends to be with students instead of with me. You can also email me, but you need to make sure you give me enough time to respond. If you don't, I will not give you credit or extra time for something on it. That's just not how it works. You need to give me extra time, or you also need to post a question. Show up to my student session. If you get stuck on something, you guys can always go to my student session. You're not obligated to stay. But with LabFlow, it would be better if you emailed me the day before so that I could go through whatever it is you're asking, and then I can work with you on that as well. Okay? Have a good night.